Good evening, everyone. So, welcome to this week two of the live discussion sessions on the foundations of our software course. So, my name is Suraj, and I will continue having these discussions with you where we'll basically go through the materials covered during the week's lectures, and we'll also try to clarify doubts and confusions if you have any. So, let's wait a couple more minutes so that people who are joining can join, and then we'll start. Okay, so I think it's a good time to start the discussion. So, recapitulating what we were discussing last time, so basically we had started with looking at how to install R and then what does the interface look like. And then we had also delved into some details regarding the integrated development environment known as R Studio. So I hope by now you have all installed these softwares and you're familiar with the interface and how different parts of these softwares work. But if you still have some doubts regarding the installation procedure or with respect to the interface, feel free to ask now. So does anyone have any doubts regarding the installation? If not, then we can start today's discussion. So I'll start by sharing my screen. Please let me know if the screen is visible and also if I'm audible.
Yes, you're audible and audible through this.
Thanks.
Not audible as well.
Okay, so let's go back to where we were last time. So if you remember, we were working with R Studio and this is what the starting interface looked like. So you had this console at the lower left corner. Upper left corner you had the option of writing a script. It's known as the R script. I'll spend some more time on R script today. Then on the right hand side, on top you have this environment or history or tutorial pane, where environment basically shows you the variables once those variables are declared. So for example, let's say, okay, so once again, repeating what I had mentioned last time, if you want to clean this console screen, all you have to do is press Ctrl and L. So that does the job. And okay, let's define some variable. Then that variable shows up in this environment pane. And if you define multiple variables, I mean, whether they are just, simple numbers, or let's say you are defining some character, then all of that will show up here, and this will stay here till you free the environment. So if you need these variables for your calculation or for your analysis, you can see them here. But if you change the values of certain variables, let's say if I make a equals 6, then you can see the value has changed. Or let's say C referred to a word, but now I want this to be a number. So these kind of changes will be reflected here, and it's easy to keep track of the variables, especially if you are doing a longer calculation or longer analysis. And sometimes people mistakenly reuse the same variable name again and again. So in that case, you can track that, okay, if I defined A earlier and I wanted it to stay at a value of 5, but at some point in your calculation you're seeing that A has become 10, then maybe you have done some mistake. So this environment pane is helpful to keep track of those things. But another thing is that if you want to start afresh and you are not reloading RStudio, you want to reuse these variable names, you can simply clear this environment. So now if I type A here in the console, it will say object A not found, because I've just cleared it out of the environment. Now another useful thing here is history. So if you want to look at your command history, so that shows up here. And there's some extra commands which I was playing around with previously, so those also appear here. So these are the only two relevant pieces for us. Lower right corner you have files, which basically shows you in the current folder what is there. You can use this up arrow to go to the folder above this. So I'm inside this R course folder, and you can create new files from here, you can delete files from here, you can rename files from here, you can do all those basic tasks. You can make a new folder, so all that is convenient. Now later on in this course, if you come across plots, then if some of your code results in a plot, then that plot will be shown here. You have to select the plots pane, change it from files to plots, and that will be shown here. And the option is you can export that plot as an image or a PDF, and based on your requirement. Okay, I have one small request to all of you. Please try to join the discussion by 5:05. I mean, latest by 5:05, because otherwise, when I'm trying to discuss something and then people are still trying to, enter the discussion meeting, so it becomes a bit of a distraction because I have to change the window again and again. So please try to be present by 5:05. Okay, additionally, we have also seen that there's this packages. So I will repeat once again. What this shows is the list of packages that is installed on my system. This is not the list of packages that come with R or RStudio. So for you, this may look a bit different depending on how many packages you have installed. Now, the ones that have a check mark next to them, that basically means that everything inside that package is already available to me to use in my console session. The ones that do not have a check mark, that I'll have to make them available. Let's say I want this CLI to be available, or the example that we were using last time, ggplot2. So what I'll have to do is I'll have to call this library command and then name the package. And now you'll see a tick mark has appeared next to ggplot2. So I'll repeat again. Tick mark does not mean that the library is installed, and absence of tick mark does not mean that the library is not installed. Everything that you see here, all the packages are installed on my system. but the ones with the tick mark are available to use in the console session. If you want to use other packages which are installed but not available, you will use this library command. Now someone had asked what is the necessity of this? Why this separation of not having all packages available to the console? That is because depending on your need, these packages can be large files. These contain a lot of functions, some of them contain classes, and if you don't need them, so the moment you make them available, they get available to the RAM. So that's where they are stored while the console session is running. And you don't want to overpopulate your RAM because then your system will become slow and your analysis will be affected because of that. So that is the advantage of this. Now let's say I will clear history. I'll clear this as well. If there is any variables, so there are no variables. So let's see. Now, one more thing, someone had asked that, okay, we can save our scripts. Again, I'll come back to our scripts in a moment. But can we save what's written in the console? I mean, of course we have the history available, but what about later on? So if I want to load something that I had done in the console. So what you can do is, let's again define a equals 5, b equals 6. And let's say I go ahead and close the R session. So this automatically asks save workspace image to rcourse /.rdata. So let's say I save it here. Now RStudio is closed, but if I reopen it, then basically you see there is this .rdata inside your rcourse folder. And if I load something from here, that basically loads the values that were previously defined. Okay, I should have done one more thing so that this was more clear. So let's clear out the objects first. Then I'll close RStudio. Don't save it this time. Now when I open RStudio, okay, let's clear this out. Now if I load from our data, it will bring back those values because these were saved in .rdata. So for some reason, let's say, now normally if you're working on big projects, you'll work with scripts. You will not write everything in the console. You'll only use console for some small tasks, small testing and printing and all those things. But for some reason, if you are doing some short calculation in the console and you have to, close it, and you can save it in .rdata, and once you reopen RStudio, you'll have the option to load the variables again from this .rdata file. Okay, let's clean this out again. Now, there's one more thing we had discussed last time, was of multi-line statements. So say if I write 1 plus 2, that's just a one-line statement, but if I 1 plus 2 times, and what if I press an enter here? So R knows that once you are conducting this multiplication operation, you have to multiply two numbers. So this command, so forget about 1 plus, but 2 times, it has to be something else as well. So R knows that this is still incomplete, so it's giving you this prompt. If you put a number here, right, basically following the BODMAS rule, 2 times 4, and then that gets added to 1, that becomes 9. Now one thing I want to bring to your attention is, usually when we are pressing enter, of course the line is coming to an end. But what happens if I do something like this? 1 plus 2 times, if I put a semicolon there, you see this is wrong. But 1 plus 2 semicolon plus. So semicolon automatically declares that the line has ended. Okay, so whatever is up to here, that will get executed, and that's the only part that will be considered as one full line. Okay, so now it's always useful when we are working in a coding environment to be familiar with some shortcuts, and some of the most useful shortcuts are ones which, you know, interrupt the code. Now you'll ask, why do you need to interrupt the code? Sometimes it may happen that you have written a loop which is an infinite loop, so the loop will keep running forever. So what to do in that case? Now first of all, okay, let's complete this one. First of all, how do we write a loop? So I want to bring to your attention one really great feature of RStudio, which is called code completion. Let's say I know that there is something called a for loop, but I don't know the syntax. So if I just write for, you see what's written here. So there's for, and then in the curly brackets written snippet. So what that means is that it will give you a sample of the code of how this for loop works in R. So if I click on it, so this is the syntax for loop. So for some variable which is in a vector. So let's call the variable x, and let's declare the vector as from 1 to 100. And what do we want to do with that? So we just want to print x. So 1 to 100 is fine. So R is sufficiently fast for these numerical purposes. And you see 1 to 100 is printed. But let's say instead of 100, I put many zeros there. Right, so what will happen is this will keep going, keep going. So if I want to interrupt that, all I have to do is press escape. So the escape key, which is on the left hand corner of your keyboard, and this will basically stop the execution of the command, and it will take you back to the console. Now if you actually want to print 1 million numbers or 1 billion numbers, then of course you want to run the entire loop. But let's say this was a mistake and you did not want to run this loop for so long, or in case you are in some other execution which is taking a lot of time and you have recognized that there is an error in the code, you can just hit escape and it will take you out, and you can continue working on what you are focused on, basically. So let's clear everything out again. Now there was one question last time, that what is the difference between console and a terminal? So drawing on that, let's try to see some more capabilities of your R console, and in some ways where it can be compared with a terminal. So as I had mentioned previously, a console is more restricted. It is for a specific purpose, especially in this context of R programming. The R console is restricted to, to be used as a calculator or to run R commands, but you can't do system level things. You cannot install, let's say you want to install a browser. You can't do that on the R console. You can install R libraries, but you cannot install system-wide applications there, or so other system-wide things. But there are some capabilities. So let's say there are some commands. So ls. What does this do? It lists everything that is, all the objects that have been, that are present in your session. So since my environment is empty, it just shows a character 0. Now another useful command is this get wd, which means get working directory. So if you click on this, it basically shows you the address of the current folder. Now this may look a bit different on your computer, because if you are using Windows, then this will show up as C:/ then users, then whatever the name of the user is, and then following the path up to where you are. But in Unix or you know Linux and Mac like systems, it appears in a slightly different manner. Now one more thing that you can do is change the directory from here. So now if you are aware of you know Linux, let's say, or so I'm working on a Mac, this is a Unix like system, so the equivalent command there is not get wd, it's pwd, the present working directory. But this is slightly different. Get wd is get working directory, and this is an R specific command. Now you can also change the folder. So let's say you do set wd. Now let's say you want to switch to a folder which is within the folder that you already are. So we are inside this R course folder, and you want to create a new folder inside the R course folder. Now of course you can do it here. You can click on the new folder and name a folder and do all that. But setwd command is, so if you're working in the R interface, not in R studio, then you don't have this right hand side. So all you have is this console. So it's good to be familiar with the commands. So setwd, now when naming paths, okay, also note the difference between / and / when you are working in Unix like system or when you are working in Windows. So here I have this /, but in Windows you'll have a /. Now this one thing, now what does dot mean? So whenever you are referring to a path or a directory, dot basically refers to the current path. So dot is just what the output of getwd was. Let's say I want to create a folder, demo. Now this is saying that there is an error. It cannot change the working directory. Why is that? Can one of you take a guess why it cannot change the directory from R course to demo?
Because the file had not been saved.
सर मूव नहीं करी उसको RM जो हमारा कोड है.
नहीं, so you don't have to move the code. So it is not currently being used. Okay, I'll give you a hint. So look at this files.
Sir, can you explain again?
Sorry.
Can you explain again?
Okay, I'm asking this question that, okay, when I ask for get working directory, it shows me that I am inside this R course directory. But when I want it to set to a new directory, which is /demo, meaning a folder called demo inside the R course folder, then it is showing an error.
Sir, you haven't given the complete path.
No. So dot basically means this whole thing. So dot actually refers to the output of getwd. Anyone? Can you try and guess? You can look at this right hand side window and then maybe you can guess why it is not changing the directory to demo.
Sir, because the demo subfolder doesn't exist.
Correct. So setwd does not create a new folder, it changes the folder. So unless you have this demo folder, this will not work. Okay, let's say that we have this folder demo. Okay, now what? So now if we give the command, you see on top, earlier it was just showing this ~r course. Now it's showing ~r course /demo. So if I do get wd again, now we are inside the demo folder. And speaking of dot and double dot, so if I set wd to dot, that means I am staying within the same folder. But if I set it to double dot, then that means I am going one folder up. So now I am back inside the R course folder. That can be confirmed by looking at this getwd command. So these are some shortcuts that you can use. From here, let's say if we can remove the demo folder or not. Okay, so this rm command only works with objects, not with folders. Now one thing you may have noted that while defining variables, we can interchangeably use two symbols. You can say a left arrow 2. What this does is it basically binds this value 2 to the variable a. Alternatively, I can also do the good old fashioned equals sign, b equals 3, and that does the same task. So you can use either one of those. The next thing we need to know is what kind of, okay, so before going to the types of objects that you can create, let's have a short discussion on this R script. So let's say I save this guy. I call this again demo.r.
So please can you increase the font? It's not very, the clarity, there's not much clarity. Please can you increase the font?
Is it better now?
Yeah, thank you.
Okay.
Thank you.
Okay, let me bring this one down. Okay, and this is another advantage of working in RStudio, that you can change this font size. So if you are working on a Mac, the shortcut is Command and plus, and on Windows it is Control Shift and plus. So that will increase the size of all the windows. Okay, now coming back to this R script. Let's say I define some things here. X equals 12, y equals 13, something like this. And let's say I say print hello. Now things that I can do with this R script. The first one, you see this symbol which says run the current line or selection. So this will basically run wherever the command where your cursor is located. So here nothing is written on line number 5. So that's why nothing was returned. If I put my cursor back to the previous line which says print hello, this will print hello. And if I select multiple lines like this, so from 2, 3, 4, and then if I do it, see both the things are done. So now y equals 13 is declared and print hello is executed, and y equals 13 appears in your environment. Now let's say you have a long script and you want everything that you have defined in that script to be made available. This is also important, that now that this y is available in the environment, you can do things with it. So you can call y plus 2, or you can change y equals y plus 2. You can give a new value to y. You can manipulate it the way you want. So let's say you have a long R script. You have several commands written there, several variables defined, or you have some functions defined, and you want to use them in your console session. And what you can do is click on this source command. It says source the contents of the active document. So doing that, you see it executes this source command, and now everything is available. Now see, y has changed back to 13 because I ran the source command after I had changed the y's value. So this becomes a reassignment and y becomes 13 again. X now appears. Previously I had not selected x. I was doing it line by line. But so that's one difference between this running and sourcing. So when you source the entire file. When you run, you can choose to run 1 line, 2 lines, as per your requirement. Okay, so there isn't a lot more that I want to discuss about R scripts at this stage. So I'll close this so that we have a better view of the console, and we'll work with the console. So now, okay, now we can focus on the different types of objects that we can have in R. So when I say, let's say A and it's returning 2, now one thing I can check is this, using this type of command, I can check what is the type of A, and it says double. Now let's say I have C equals 8.97, and again I do type of C, again it says double. Now if you look at it, it appears that 2 is an integer, but R is saying that this is a double. So what is happening here? So what's happening is, whether you define a decimal number or a floating point number or a fractional number, anything, let's say C is 2 by 3. By default, all these numerical quantities are stored as doubles in R. Now what is the difference between double and integer? And how do we explicitly differentiate that in R? So the difference comes with respect to how these values are stored in your computer memory. So since integers have no fractional parts, so let's say if this 13 or this 12, if this was just an integer, you just have to store the value 12 somewhere. There is some conversion when you convert from this high level language to the low level machine code. But there is one way of storing these numbers. But when you have something fractional like this, 0.666 and so on, you have to store two different things. What is before the decimal, what is after the decimal. And their storage is slightly different. So this part, whatever is before the decimal, is stored like a integer. Whatever is after the decimal is stored like, it is called mantissa, but we'll not go into details about that. But R doesn't want to, every time convert from integer to double, double to integer and so on. So by default, it treats everything as double, which is fractional values or decimal values. And you can do all operations on them. Now there is one difference if you have done coding in C or some other language like that. In C, if you define A equals 2, then of course in C you also have to mention that you have to write something like int A equals 2. So you have to say it explicitly that A is an integer. And then if you do something like 2 by 3 in C, then C will just give you 0, because C would take this as an integer, this as an integer. The answer is 0.6667. So what C knows is that, okay, divide integer by integer, you get an integer, which is not always true, but that's how the computer memory works. So it will just pick out this part, the integer part, which is the part before the decimal, and it will discard everything else, because the integer has no mechanism of storing these values. Now, but what if you want to explicitly declare an integer in R? So let's say I want to convert this A. Now, one way of doing this is you put this capital L next to the number. Okay, so now if you do type of A, it will say integer. Now, but all of these, so integers or doubles, they are numbers. And that can be verified by this command, is.numeric.
Sir?
Yeah.
Sir, what is the difference between type of and mode commands?
Type of, basically, so type of is more an upper level thing. It just differentiates based on how you have defined things. Okay, so let's say I define something new. So D equals hello. And if I do type of D, let's say that this is a character. Now mode command is more concerned with the lower level thing, which is how it is being stored. So in some way, mode actually reflects what type of is saying. So if I do mode of A, which was an integer, it says numeric. But if I do storage mode of A, it will say integer. So these are some small differences. Type of just gives you clarity what you are dealing with based on how you have defined things. Because here A has explicitly been defined as an integer, so type of will tell you that this is an integer. Now here C is explicitly defined as a floating point number or a number which has a fractional part, so it shows you that this is double. Mode and storage.mode are more lower level things. So there are differences in how numbers are stored and how characters are stored. So those differences become clear when you do mode. But since in this course I don't think we'll go too much into details about the memory management and the lower level stuff. Basically R is not that kind of programming language where you go deep into the machine code and figure out what's happening at the level of your processor or at the level of your memory. So for our purposes, type of is sufficient to figure out the differences between the different kinds of variables or objects that we are using. Now, one more useful thing that you can do, just like you have this is dot, okay, so you can check if something is a number. So let's say x. So we have x defined here. Do we expect this to be, what do we expect the output to be here? Can someone tell me? So I'm asking, is x numeric?
2.
Sir, it is answered in true or false, no?
Yeah. So now, one interesting thing here. This is dot numeric, that is a function. And you are applying that function to this variable x and it is giving you some output. This output itself is some object and you can store that object in something. So let's say I come back here. Let me call it a variable var. You see, this value of true is stored inside var. And if I am hovering over it, so maybe you can see my screen. So just below the cursor, it says logical, 56 bytes. Right? Can you see that small rectangle there? Just below VAR. One of you can.
Sir, what is the meaning of logical?
I'll come to that, but just confirm that. Can you see this rectangle there?
Yes, sir.
Okay. Logical is basically another type of object that you can create in R. And that object can have only two values, either true or false. So if I ask, let's say 3 greater than 4, that's false. Let's say 23 times 6 is less than 9 times 18, which is true. So some operation is done, but there is a relational operation here, right? Are two quantities equal? Is one quantity greater than the other? Is this object the same as the other object? So these kind of questions are answered in true-false fashion. And this is the logical type. So now if I check the type of VAR, it says logical, because it can only be true or false. Now from this, let's move into let's bring out an important point here. The way this true is written, all capital, that is important because R is case sensitive. So now if I put VAR equals TRUE, now see, it is giving me a hint that I should use TRUE because it already knows that var is a logical type. And the logical type can only have true or false values, all capital. But let's say I persist and say, no, I want small TRUE. this will throw an error for two reasons. First of all, I have not defined a variable called true. So if I had defined something like true equals 6 and then put var equals true, then var would have become 6. But the second important thing to keep in mind is R is case sensitive. So this all caps true and this all lower caps true are not the same thing. So only this all caps true and all caps false, these are the only two logical objects. Not this guy, not something like this, or this, or any other combination. So this has to be kept in mind. Another thing that we should keep in mind is, let's say if I put true, what if I want to assign a value to this? I say that the name of my variable is true, written in all capital. This says that this is invalid. Why is that? Because all caps true, or same thing for false, this is a reserved keyword in R. So all programming languages have some reserved keywords that you cannot use to define as variables. Now reserved keywords are important for a programming language to function properly, but they are also important to, eliminate possible sources of confusion. So some of the most popular reserved keywords are, so in any programming language you can have this question of if, right? If 2 is greater than 3, okay, it expects parenthesis, then it expects something to be done, print, yes. It did not print anything because 2 is not greater than 3. But the point is, if has a specific purpose, right? You cannot assign a variable to if. You can't say if equals 1, because if is also a reserved keyword. Same thing that we saw a for loop earlier in the discussion. So I cannot say for equals, let's say, loop. Again, this is wrong because for is also a reserved word. But you see, print equals 5 works. I can define a variable called print. So this is where it gets a bit tricky. Not all function names are reserved keywords. So print is a function that prints whatever you tell it to print. But print itself, the word print itself is not a reserved word. So you can use the word print to define a variable. But you should not do that. So while writing any code or while conducting an analysis, one of your focus should be to maintain clarity in what you're writing. So if you start reusing variable names, or if you name your variables after some functions, then that will end up leading to a lot of confusion as the program becomes bigger and bigger. But this is what you have to be careful about. So, because sometimes you are allowed to so now one more thing, you can redefine a variable, but even though you have used this print as a variable name, it does not change what you can do with print. So print 5 will still print 5. So this is not overwriting this, like that what was happening with variables. Like if I say I have a equals 2, which is an integer, if I make a equals 21, the value changes. But if you name a variable after a function name, the function is still preserved. But this is tricky, so be careful with that and don't name your variables after functions. And anyways, if you try to name your variables after some reserved keywords, this will be problematic. I mean, R won't allow that. So now a few more useful reserved keywords are, let's say, there is NA, which is not applicable.
Sure.
Yeah.
If we put a bracket 5, then there is an error, right?
There is an error because it says you cannot find the function a, because there is no function named a.
Sir, but the values is there, no a.
No, but R doesn't know what to do with 5.
Okay.
The moment, so that's the difference between an assignment and a function call. What you are doing with a equals 3 or a left arrow 3, you are binding this value 3 to a. This is an assignment. But the moment you write something like a parenthesis 3, this is the syntax for a function call. So what R expects is that somewhere, maybe in this session or somewhere in the environment, there is a function defined as a. But it can't find that function because that we never defined a function like that. So, but if I do something like, let's say, type of, then that gives you an answer. Why? Because you see, when you start typing type of, it shows next to it in curly brackets base. So type of is a function which is available in your base package. So R is aware of that fact that okay, type of is a function. So this will not throw an error. But there is no function called a. You'll have to define a function called a. So let's say, okay, this will be covered much later in the course, but
Sir,
yeah.
but if we write type of A, then the answer is coming double only.
Yes, because we have assigned this a equals 21. Na? So a is a double object.
So if we write type of print, then what it will call?
Let's see. Because of this assignment. One funny thing we can do is we can maybe check type of. Now this goes into a closure, and what is a closure, which is a bit of an advanced topic, but let's say we go to help and search what a closure is. Yeah, so closure is related to function definitions. So, and that is what we expect because type of is a function which gives you an output. Now, okay, let's say, why isn't it saying that type of print is also closure? Why it is saying it's double? Because it's referring to what's here in your environment. So let's say if I free this, oh, let's clean everything out. And then if we do type of print, then it says closure. Because now there is no variable named print defined. Now that is another reason why it's dangerous to name variables after function names. Because let's say there's a part of your code which actually examines the object. And based on, so your code is reading someone else's code, or your code is trying to read a text file where some things are written, and it's trying to differentiate which of those are functions, which of those are variables, and so on. Now let's say print comes within that text file or something, and at that moment the author of that file is referring to the print function. But if the author of that file has also defined print equals 5, then whenever you do type of print, it will return double. It will not return closure. So, and that is wrong basically, because you are not looking for that variable print. You are looking for this function print. So these are a few things one needs to be careful about. Now another few things. So there's this NaN, which is not a number. So what is not a number? So if we try to do 0 by 0, then that is not a number, because division by 0 is not defined, but multiplication by 0 says that it should be 0. So what should it be? Should it be infinity or should it be 0? So this is not a number. Similarly, infinity in R is defined as INF, capital I, small n, small f. Now if you add infinity to infinity, you get infinity. If you add any number to infinity, you still get infinity. But
Excuse me, sir.
yeah,
Sir, I was trying to compute 10 pi by 2 value through inbuilt trigonometric function. I should have got main value, but it's giving a numeric value.
so let me get back to that. Let me complete this line of thought, then I'll come to that. Okay, speaking of not a numbers, so infinity minus infinity is again not a number, because again infinity is very large, but very large plus minus something, so that's still very large. But what do you get when you subtract a very large number from a very large number? Which of them is larger? Because infinity never specifies that this is infinity above this cutoff or something like that. So infinity minus infinity is also not a number. And if you want to check whether something is infinite or not, let's say I call this infinity plus 6 is a. Just like we had the is numeric or is character, again is dot infinite. I put a here, it says true. Right. And the opposite of that is finite. Now take a guess. I've defined a as infinity plus 6. I'm asking whether a minus infinity is finite or not. What do you think the answer will be?
So false. Not a number, sir.
Not a number. So let's see how does is not finite treat not a number. It says it's false. So yeah. Okay, yeah. So coming back to the question. So what were you trying to do? Sine of
Sir, 10 of 10 pi by 2.
10 times
Sir, 10 pi by 2.
10 pi by 2. Okay.
Sir, tangent function in mathematics. TAN.
Sine of tan or just tan
Just 10 pi by 2, sir.
pi by 2. So you're saying why this is not giving infinity?
Yes, sir. I am getting not a number output when I'm using 10 pi function.
Okay.
No, sir. 10 pi is a inbuilt function in it.
Okay.
TANPI.
This one.
Yes, sir. Yes, sir. Now I'm putting in the argument 0.5.
Okay. Okay. So tan pi is basically giving you multiples of tan, right? So tan 0.5 basically means 0.5 times pi.
Yes, sir.
Okay, so let's see what does the documentation say. It says the cos pi x, sin pi x, and tan pi x are accurate for x values which are multiples of a half. But this is half. Okay, why? So let's see the type of this guy. This is a double, but I think this is probably something to do with, there's a difference between when we do by hand calculation or we try to solve something analytically and we solve the same thing computationally. So computationally, there isn't always a exact analog. So infinity in computer doesn't mean the same thing, the same notion of infinity that we have, because computers have limited storage, so they have to draw the line somewhere. That this is the maximum value that you can go up to. So this production of nan. So I guess the expectation would be that this should give an infinity, not a nan. It's not infinite. So maybe this has something to do with the storage. Or I think another possibility could be that tan pi is actually what? Sine pi by cos pi, right? So if I write cos pi of 0.5, and that is 0. And it's giving nan because of the zero division error. So it's not immediately transferring that to infinity. So let's say if I do 1 by 0, it goes infinity. But sine pi of 0.5 is 1. This is a bit peculiar. So sine pi by cos pi gives infinity, but tan pi is not giving infinity. I think one reason could be that normally when you draw the plot for tan theta or tan x, you see, if you draw it from between minus pi by 2 to pi by 2, it doesn't exactly become infinity. It asymptotically reaches minus infinity and plus infinity or the two ends, right? So maybe by calling it a nan, it is saying that, okay, this is not the exact value there, but this is a number that we cannot quantify. This is larger than anything that we can store, and we don't have a description for this, so we call it not a number.
So,
Yeah.
so the INF is for the infinity, it is a separate variable or it's a separate type of data type? That's why it's showing like this, or is it a mathematical error that is caused in the computer?
No, INF is of a double type, so its value is some very large double number. So it's an
Okay.
approximation. It is not the actual infinity that we come across in mathematics. So computationally, it is some bound on both sides. The same thing if you do minus infinity. And let's say if you put you cannot put L next to it like other double quantities to make it an integer. So there's this. So this was the discussion for reserved keywords, not a numbers, and infinite quantities. Now one more important thing. So far the kind of data that we have worked with is scalar data. So we say A equals 0, B equals 7, A times B. So these are all scalar data. So one variable assigned one value to it. And these operations are also what are known as scalar operations. So involving two scalars, and the result is also a scalar. Now, but that's not what we want to restrict ourselves to. We want to, utilize broader capabilities of R. So one jumping point here is from scalar we qualify to vector. So how do we define vector? So one thing we had seen last time also, that if I say x is from 1 to 20, and this automatically defines a vector. So if I do is dot vector x, it's true. Now I have one question for all of you. Now so far we have seen that type of A, type of B, even if we have defined them as just integers without any decimal or a fractional part, it is stored as a double. But when I did type of x, it says integer. Can you try to guess why? I mean, why is x being stored as an integer and not as double? What is so special about this 1 to 20 definition?
As it's a vector data type, as it converts all data into one data type, vectors usually do that, right?
You can make a vector of, okay, I'll come to the how to define data vectors, but you can define vector of doubles. So why not this? I mean, what is special about this definition, 1:20?
Sir, in the numbers from 1 to 20, there are so many doubles. There are so many floating point numbers.
Yes. So
I mean, infinitely many.
okay. So in case I have
So I think it's of int data type.
Okay, so let me clarify that a bit more. So the thing is, it's the syntax of this definition 1 to 20. What this does is it gives you equally spaced numbers from 1 to 20. And as it was correctly pointed out, that if R has to guess and decide how many doubles should I give in this range, then there's no one correct answer to that. Right? You can have a 0.5 separation, you can have a 0.25, 0.01, you can have many numbers. So what it does is automatically, if you treat them as integers, you can have equally spaced by 1 unit, so 1, 2, 3, 4, and you can have 20 numbers. That's basically what this command does. But let's say we don't always want a continuous sequence of integers. So what do we do in that case? So what we use is this C. Now this C, let's say I want 1, 3, 6, 98, 27, something like this. Now this is a collection of values 1, 3, 6, 98, 27. And what this C does, outside of the parenthesis, it basically combines or collects all these values together. Okay, so now if I execute this, so y is a vector of 5 elements of numeric type. And if I do type of y, then it's a double. Okay, so now there is no guesswork has to be done. How many numbers, what kind of spacing has to be done. This is exactly the sequence that I have defined, and using this C, I have collected them together. So that becomes double. Now similar to how we could define...
In the first statement of where you assign x as 1 to 20, can you put that as a vector like C of 1 to 20?
Well, we'll do the same thing. So let's see if we can do that or not. So this may give a syntax error. It gives you the same thing. So let's change this. So this also works. But that's not necessary, right? Because this is already giving you a vector. So
okay, sir.
Now type of y we have seen is double, but let's say instead of double we wanted this also to be an integer. So what we'll do is we'll place this capital L next to each of them. So now if I do type of y, this is an integer. Okay. So now we have seen scalar operations. So next thing we can look at is scalar vector operations. So what happens if I say y plus b? So y is this guy, which has 5 elements. B is just a single number. So if I do y plus b, it does an element wise addition. So this b is added to each of the members of y. So 1 plus 7 becomes 8, 3 plus 7 becomes 10, 6 plus 7 13, 98 plus 7 105, 27 plus 7 34, and so on. And maybe you can take a guess what will happen if I do y multiplied by b. Can anybody try? Hello?
Yes, sir. Can you go to the previous screen that you had?
Yeah, I'm asking what happens if I do y multiplied by b. What do you expect?
Each element of the y vector gets multiplied by 7.
Exactly. So y was just 1, 3, 6, 98, 27, and everything gets multiplied by 7. So I think next week we'll get into more complicated stuff, vector operations, so how do two vectors interact with each other, and we'll also maybe highlight operator precedence. But one thing I can mention now itself is, if you have multiple operations, so let's stay with 2 plus 4 times 8 minus 9 divided by 2, something like this. The order in which these operations are done follows basically the BODMAS rule. So forget about B and O because we don't have any brackets and we're not saying off anywhere. So division, multiplication, addition, and subtraction. And if you don't want that sequence to be followed, so you can see 9 divided by 2 is 4.5, right? 4 times 8 is 32. So 32 plus 2, 34 minus 4.5 is 29.5. But if you want to change the sequence, obviously what you can do is put some brackets. So you want to add 2 and 4 first, and you want to subtract 8 and 9, and this gives you minus 3. So 6 times minus 1 is minus 6, divided by 2 is minus 3. Now, one important point to note is that in normal mathematics, we have several varieties of brackets, right? We have this guy, we have the curly braces. But if you do that here, this will throw an error. Because in R, just like in most programming languages, as far as mathematical operations are concerned, the only brackets that we can use are these small brackets, the round brackets or the parentheses. Curly brackets have a different meaning entirely, and similarly the big brackets also are used for special purposes. Now one last point is regarding the use of blank spaces. So if I write it like this, okay, let me correct the brackets. If I do something like this, this does not make any difference. Okay, the reason being, the extra white spaces are not treated as any special characters. They are just skipped. So even here, when we have given some space before and after plus, before and after minus, basically before and after each operation, that's just for our clarity. So we can read it and display it properly. R basically sees it as 2 plus 4. It does not see the white space in between. The white space is seen if you, let's say, define W equals hello world. So inside a character you can put a space. So this is different from this hello world. Okay, so in normal calculation, blank spaces don't have any meaning. Now one question someone had asked last time, that speaking of these mathematical operations, now I had mentioned that this percentage sign does not refer to the modulus or taking the remainder. So someone had asked, what is the symbol for taking the remainder in R? So it is nothing but 2 percentage signs. So if you do something more complicated like, so instead of 1 percentage sign, R works with 2 percentage signs. And as far as exponentiation is concerned, you can do it like this. 4 to the power 8 can be written as 4 star star 8, or alternatively, you can just write this symbol. Both of them work in the same way. Okay. So I think this is where I'll wrap today's discussion. But before leaving, if you have any doubts, any questions, please feel free to ask now.
Sir, what will happen if we put L after in the variable of x where you first declared it?
Where? So
The first time you declared x in this console.
This one?
Yeah. Yes, sir. If you put L after 1 and 2 or 20,
let's see.
What will happen?
So this is already an integer, right? So even if you put L, it doesn't change anything. It's still the same. L basically explicitly tells you that this is an integer, but this mode of defining an array by putting a colon and defining a sequence already produces an integer. So if something is already producing an integer and you are explicitly also telling it to produce an integer, it will just do the same thing, produce an integer.
If a decimal inside a vector is named as L after like a C of 2.3 L.
Good question, good question. So basically, let's copy this one. And I want you to take a guess. Will this throw an error or will this just throw away the decimal part? What do you think?
Sir, I guess it will convert that to a integer value.
It's throwing an error.
Error.
So if you want to do that, I'm not sure if you can integer if I do 1.09. So if you want to do that explicitly, you have to use this command as.integer. So then this will throw away.
Okay, sir. Thank you.
Now, again, let me repeat about this code completion feature in RStudio. So you have this is, you have this as. So as basically helps you to convert from one type to another. What you can convert into, so as dot character, as dot complex. So okay, let's take an example for this complex also. So if I put 3 plus 7i, this is a complex number. So if I check the type of this, or let me define this as a variable and check the type of the variable. This is z, and I do type of z is complex. So now if I want to convert this to integer, let's say if this works or not. So it just throws out the imaginary part and gives you the real part as the integer. Now let's make it slightly more complicated. So let's call it 3.98 plus 7i. Okay, and now we want to do this as integer z. So again, it throws out the imaginary part, it also throws out the fractional part. It just gives you the integer part. Now one more thing you can do is, let's say if I change this to character, this whole thing 3.98 plus 7i is no longer a number. So you can't do, okay, let's, when this is a new variable, w equals character version of z. So if I look at the type of w, so type of z is still complex, but type of w is a character. If I do something like w plus 2, this will throw an error because this is no longer.
So does it have as double kind of a function?
I think so.
If you put z in that argument, what will happen?
It just throws out the imaginary part and gives you the double real part.
Okay, sir.
Okay, so do you guys think this is a good place to stop for this week? Or are there any more doubts or any more points that you want some clarity on? Remember, you can go through, the week's lectures. I think the best way to learn is while following the lectures, you can open RStudio or R interface and code along. So as the instructor is typing the code in his console, you can pause the video, type the same there, and then check if you're getting the same answer or not. If you're not getting the same answer, check for errors. If you're still having some confusion, you can note it down and ask in these Saturday sessions. Now, even in these Saturday sessions, the best way to learn is just type along as I am typing. So you can see that the same command gives the same output. And if it is not giving the same output, then maybe there is some discrepancy. Then we can discuss that discrepancy, that why that error is happening or why there is a mismatch. So, are there any more questions?
No, sir. Thank you.
Okay, thank you to all of you. So I'll see you next week then.
Thank you, sir.